Hello class, and welcome to Chapter 8, which is going to focus on quadratic functions. Today's first lesson, Section 8.1, is going to be about the key features of the quadratic function. By the end of today's lesson, you'll be able to identify those key features for the parent graph, so for the original graph of a quadratic function. So a quadratic function is a nonlinear function, so some sort of a curve, that is written in the form f of x equals ax squared plus bx plus c, where the a can't equal 0. The reason a can't equal 0 is if I do 0 times x squared, that's going to turn into 0, which would mean the x squared would cancel out, which would leave us with just a regular linear equation. So that a has to be some sort of a number. The particular shape of a quadratic graph is called a parabola. So it's going to be a curved shape, and it's going to look like this. This pictured right here is what we call the parent function. That's this f of x equals x squared. That is the most basic quadratic function we can get. There's nothing being added or subtracted, multiplied, divided, anything. It's just the basic x squared function. A few key features of this parent graph. First is the axis of symmetry. All parabolas have an axis of symmetry. They are perfectly symmetrical. In the case of the parent function, the axis of symmetry is going to be where x equals 0, aka the y-axis. So if I took that graph and folded it in half on that green line, the two halves would match up perfectly. You can see that negative 1 matches up with 1, 1. Negative 2, 4 matches up with positive 2, 4, which you can also see in the table that were the coordinates used to make this parent function. Another point we want to highlight is the vertex. This is the lowest or highest point of a parabola. The vertex of the parent function is the origin, that 0, 0 point. That's where we go from in this case, decreasing, and we change to increasing. It's also the place where this parabola, this curve, touches the axis of symmetry. So the point for the vertex is always going to be where the axis of symmetry touches our parabola. The last key feature of the parent function is that it opens up. What this means is that the open space in our graph is moving up. We also will see parabolas that open down, where the open space is facing down. But our parent function, a key feature is that it opens up. So now you can see, again in red, this parent function that hasn't moved. We still have our point at 1, 1, and negative 2, 4, 1, 1, and 2, 4. So we still have those original functions. So I want you to take a minute, try on your own, identify how the blue function compares to the red function, and identify how the green function, this green line, compares to the red function. For the blue one, you'll notice that this graph has shrunk inside of the red line. So when we have something that looks like this, we're going to say that it has gotten narrower than the parent function, and the green line has gotten wider than the parent function. So they all are still opening up. They all still have that vertex at 0, 0. We're just changing how wide or how narrow the function is. Notice that changed because of this number in front of x squared. Looking at another one, we have again that original red function, negative 1, 1, negative 2, 4, 1, 1, 2, 4. And now we have this new blue function, g of x is equal to negative x squared. Go ahead and take a minute to say how this one changes compared to that original red function. So in this case, the change is that instead of opening up, this new blue function opens down. So instead of our curve going up, our curve is going down. Notice the points have just flip-flopped. Negative 1 is now at negative 1. Negative 2 is at negative 4. 1 is at negative 1. 2 is at -4. So we took all of those points and flipped them over the x-axis. That occurred because of the negative. So a quick summary. If you have an a value in front of x squared, and that a is between 0 and 1, so 0.5 or 1/3 or -2 or -0.2. It's between 0 and 1 because we're looking at the absolute value. So when you're deciding wider or narrower, don't pay attention to any negatives. If it is narrower, it's going to be greater than 1. So 2, 7, -9. Again, not paying attention to the negatives. The negative comes into play when you're looking for open up or open down. Open up is going to be anything bigger than 0. So 0.75 or 3 or 2 2/3. All of those are bigger than 0, so it's going to open our graph up. And the open down would be anything less than 0. So -1/2, -6, -1 1/4. All of those are going to flip our parabola so it opens downward. So if we're looking at these equations, I've got j of x equals -2x squared. It wants us to identify what the changes are. So that negative tells me that I'm going to have a change and it's going to open down. The 2 is bigger than 1, so that's going to tell me it gets narrower. Go ahead and identify the change for k of x on your own. Our change here is simply that it gets wider. There's no negative, so we're not changing the open up or down. It's between 0 and 1, so it is getting wider. Next thing we're going to look at is when the graph increases and when the graph decreases. So for what interval does f of x equal 4x squared increase, and for what interval does it decrease? When you're doing this, look at the table. You are looking for when the numbers are going up and when the numbers are going down. So from 16 to 4, we're going down. From 4 to 0, we're going down. Then we switch, and from 0 to 4, we're going up. From 4 to 16, we're going up. So our interval then for the increase is going to be the numbers, the x values where we are increasing. So anywhere bigger than 0, we are increasing. For the decreasing part, those are all of our x values that are smaller than 0. Neither of these includes equal 0 because when you're looking for increase and decrease, you're looking in between a point. So we're not saying at 0 it's going up or down. At 0, it's just equal to 0. So for all the numbers bigger than 0, 1, 2, 3, 4, these answer values, the f of x values, are going to keep getting bigger. For all of the numbers smaller than 0, -1, -2, -3, etc., our answers are going to keep getting smaller. So 16 to 4 to 0. So those are going down as you would look on the curve. We could see it was going down on the left side. We hit 0, and then it starts going up again. Go ahead and identify the intervals for f of x equals -2.5x squared, where there is an increase, and then also identify the area where there is a decrease. In this case, our increase is anything less than 0. So when I go from 0 to -2.5, or excuse me, when I go from -1 to -2.5, I'm going up. When I go from -2.5 to 0, I'm going up. Then I switch. When I go from 0 to -2.5, I'm going down. -2.5 to -1, we're going down. That's because this graph is opening down. My values are coming up, -1, -2.5, then we hit that 0, and then we start going back down. Next thing we're going to do is compare rates of change. So when we do this, one thing I want to remind you of is you're going to need to remember that slope formula, which says slope is equal to y2 minus y1 over x2 minus x1. That's how we find a rate of change. When we are doing this, you have to pay attention to the interval that they want you to use. So in this case, they're asking you the rates of change between -5 and -2. So your first step is going to be to take your first function, f, and plug in -5. So you're going to plug into your calculator, -0.5, parentheses, -5, parentheses, squared. So when it's in the calculator, it should look like this. Hit enter, and you get an answer of -12.5. Do that again then with our -2 value. So we're going to say f of -2, -0.5, parentheses, -2, parentheses, squared, and that's going to give us an answer of -2. This is our x1 and our y1, our answer, and our y2. This is our x1 and our x2. So when I plug that into the equation, I'm going to say y2, which is -2, minus -12.5, over my x2, which is -2, minus -5. Double negatives turn into a positive, which is going to give me 10.5 over 3. And when I do that division, our average rate of change on the first interval is 3.5. So it's increasing by an average of 3.5 over that interval. The next thing we need to do is then find our g of x values. So I'm going to say, okay, g of x, we start again with -5. So -1.5, parentheses, -5 squared. That answer is going to give me -37.5. Then I'm going to go ahead and plug in -2. -1.5, parentheses, -2 squared is going to give me -6. Again, we have our x1, y1, x2, y2. So I'm going to go ahead and plug that into my formula. y2, which is -6, minus y1, which is -37.5, over our x2 minus x1, which is going to be, again, -2 minus -5. Again, that's going to turn into a positive because we're subtracting negatives, which is going to give me 31.5 over 3. When I do that division, I get 10.5. So our last step here is it wants us to compare the rates of change. So what you're going to do is you're going to take your second answer, which is 10.5, and you're going to divide it by that first answer, which is 3.5. When I do that, I get an answer of 3. So what that means is on the interval of -5 to -2, so just in that particular space, g of x increases 3 times faster than f of x. Go ahead and try this one on your own, finding the rates of change between 2 and 4, and then comparing them. So for the first equation, we plug in 2 and 4, we get 3 and 12. Plug it into our slope equation, our average rate of change is 4.5. Same thing with g, plug in 2 and 4 into the slope equation, we get an answer of 9. To compare these two, we have 9 divided by 4.5, which is 2. So on that interval, 2 to 4, g of x increases 2 times faster than f of x. Last thing we're going to do is use some quadratic functions, the basic ones, to solve a few problems. So the owner of a new dance studio is installing wooden floors in all of the rooms. Write an equation to show the cost of installing a square floor. Then determine how much the owner should expect to spend on a room with 15-foot sides. So the first thing we need to consider is the fact that it's a square room. When it's a square, that means both of our sides are the same. So the area of this square would be x squared. That's how much space we have to cover. Now, it's asking about the cost. This info over here tells us that it's $8.75 per square foot. So our cost equation is going to be $8.75 times that area. Remember, when you see square feet, that means you're talking about area. Feet would just be talking about perimeter. Feet cubed would be talking about volume. So since we're talking about square feet, it's saying 875 times the area of that space. So that is our cost equation. Then, to answer the question, how much should they expect to spend if it is a 15-foot room? That means we're plugging in 15 for x, so we're going to say $8.75 times 15 squared, giving us a final answer that our cost is going to be $1,968.75. So the two answers to this equation would be the first part, that write an equation, and then our second part to determine how much they should expect to spend. So those two different answers. Go ahead and try this one on your own. In this case, again, we're looking at a square wall, so our area is still x squared. It cost us $2.15 for a can of paint. It's going to cover a square yard of wall, so that's how we get our cost equation. Then we're going to plug in our 12 yards. So we're going to say 2.15 times 12 squared, which gives us our final answer of $309.60. If you have questions about this or anything else from the lesson, please let me know when you get to class.